In this question, you will investigate a few basic movements of a robotic arm as shown in the figure 1. In this question, you will investigate a few basic movements of a robotic arm as shown in figure 1. The arm segments A and B of the robot have the ability to rotate in either direction around the joints 1 and 2 horizontal planes. The arm segments A and B of the robot have the ability to rotate in either direction around the joints 1 and 2 in the horizontal planes. Okay. So it means A section can be rotated about 1 and B section can be rotated about 2. So 1 is a point, 2 is a point. Around the point 1, A section can be rotated. Around the point 2, B section can be rotated. What about C here? The joint 3, this one. The joint 3 allows segment C to move up and down. So segment C can be moved just up and down. Move up, move down. A, B are rotatable. C is only moving upward and downward. That's the simplest thing. Right. Right. Let's go. Assume that only one movement around O across a joint is allowed at a given time. Only one movement is allowed. So A and B will be at rest when C is moving. That's the move. That's the meaning. C and A will be at rest when B is moving. B and C will be at rest when A is moving. That's the meaning of this word, right? Allowed. Assume that only one movement around O across a joint is allowed at a given time. One movement is at a time. And that is no friction in any of the joints. No friction is there with any of the joints. Right? Simple A question. First, consider upward motion of the segment C. This motion is described by the velocity time graph shown in figure 2. Now you need the knowledge of velocity time graphs. If you have not studied graph section, velocity time graph, displacement time graph, acceleration time graph, force time graphs, you must send me a message to my WhatsApp after the class. Then I can arrange some other classes for you to cover those sections. First, consider an upward motion of segment C. This motion is described by the velocity time graph figure 2. The mass of the segment C is 0.1 kilogram. Where it was C here? This one, C. So this can be just moved up and down. Move up, move down. So its motion is described by this graph. See? Initially, during the first 2 seconds, what kind of motion is there during the first 2 seconds? Lamai, what is this motion?
Uniform acceleration.
Constant acceleration. Very good. What is the motion described in the 3rd second here? From 2 to 3 seconds? Only 1 second. What is that motion here?
Constant velocity.
Velocity.
Constant velocity. Final 2 seconds, 3, 4, 5, final 2 seconds.
Deceleration.
Constant deceleration.
Constant deceleration. Clear? Now please write the heading as 2012 first essay question. Right? Write the heading 2012 first essay question. And write simple A and draw this graph. That's the first thing. Write the heading as 2012 AL first essay question. First essay question. Right? And write simple A and draw this graph. Essential. You have to do them. Start there. Right. It's better if you mark this angle as, look at board. Please mark this angle as alpha. This is angle alpha. Right. And mark this angle as beta. This is beta. And mark this distance as 2 seconds. You see, this is just 2. See, and what about this height there? What is this height, Lamai?
.1.
0.1. Very good. And what is this length? Only 1 second. Am I right? Yes. Only 1 second. Yes. This is just only 1 second. Finally, what is this length here? It is again 2. Am I right?
2 seconds.
Yeah, that is again 2 seconds. Right. Mark them all here. We need. This is only 1 second. This is 2 seconds. This height is 0.1. Right. So these things essential for you to understand the question. Right. Now my question is, right? Listen dear. Please name these points also. Name this point as, let me use a different color. Name this point as X, Y, Z. Similarly, name these points as P, Q, R. So actually, I'm discussing a question. I'm teaching you. So I'm teaching you. So I am giving you all the possible details. That's it. So I have asked you to name the first triangle as X, Y, Z. This is Y, and finally Z. The next triangle should be named as PQR. Check and mark them properly. PQR. PQR. That's it. Now we can answer the questions easily. Calculate the acceleration of the segment C during the first 2 seconds. So what is acceleration there? Acceleration equals, Lamai? Hello?
Average velocity divided by time.
No, yeah, it is true. It is true, but here it's a graph. So how do you find acceleration from a graph, dear?
Tan alpha.
Tan alpha, yes. The acceleration is calculated from a graph by the equation tan alpha. Please write there. This is the answer for Roman number 1. Acceleration is tan alpha. Right. What is tan there? You want to find tan alpha from XY is a triangle. So what is tan of a triangle?
Opposite of adjacent.
Opposite side divided by adjacent side. So opposite side is YZ, adjacent side is XY. So what is YZ there? Lamai? What is the length of YZ side?
0.1.
0.1. What is the length of XY side?
2.
2.
2.
Therefore, what is the acceleration? 0 divided by 2 is 0. 1 divided by 2 is 0. Then 10 divided by, because you have a decimal point. So 10 divided by 2 is 5. So this is the acceleration during the first 2 seconds. Complete there. Draw the graph and complete this answer. Okay. Right. Then let's go to the second question. The forces acting on C. See there. How many forces are acting on C there? The forces acting on C are its weight and the force applied by the motor. So it means there is a motor for the segment C to be moved. Right. So only two forces: weight of the segment C and the force given by the motor. Calculate the force applied by the motor during the first 2 seconds here. So during the first 2 seconds, I think this is more, yeah, consider motion, upward motion of the segment C. See, upward motion of the segment C. See this sentence here, upward motion of the segment C. Right. So how many forces are acting on the segment C here? If I draw the segment C separately here, right? So this is the segment C. They have given the forces acting on it. What are the forces acting on it, dear? Lamai? How many forces acting on the segment C, dear?
2.
2. What are the two
Two
forces?
forces.
Weight.
Weight and the force
And
applied by
force
the
applied
motor.
on motor.
Very good. Weight means gravitation, attraction, force. Gravitation, attraction force is always acting vertically downward. But here it is said that segment C is moving up. For the segment C to be moved up, the force provided by the motor should be acting upward. Am I right there? So this is the gravitation attraction force mg Newton. The segment C is moving up. What is the acceleration of the segment C during the first 2 seconds, dear? Let me mark it as A1. We have found it as 0.05 meters per square seconds. That's what we have found, right? So for the motor to be moved up, for the segment C to be moved up, there must be an upward force. So let me take that force as Fm. Fm means force given by the motor. Would you please draw this figure here? Then the story will be much clear for you. So Fm is the force given by the motor, right? Draw this figure here, please. So I'm going to answer. I'm going to give you the answer for Roman number 2. A Roman number 2. For A Roman number 2, I have drawn this figure. This is the segment C. This is the segment C here. This is C. Right. So what should I do to find the force given by the motor here? We know the mass of segment C is 0.1 kilogram. So what should I do to find the force given by the motor C?
Apply figures in me.
Yeah. Can you give a try here? Apply F equals ma. Find the force given by the motor, that is Fm, and send your answer to my Zoom chat. Start there. Right. So let's just apply F equals ma. By applying F equals ma to this segment C, you can find the acceleration. Right. So we must indicate the direction. Do not forget to indicate the direction vertically upward. Vertically upward. Let me apply the equation F equals ma. There are two forces. The upward force is Fm, downward force is mg. Therefore, the total upward force is Fm minus mg. Mass is mass of the object 0.1 kilogram. Acceleration is 0.05. Right? So Fm minus mass of the object 0.1. Simple G is 10. What is this there? If you multiply this, what will you obtain? 0.1 into 0.05. Another decimal place will be added because of this 0.1. That's the only thing happens. One more decimal point will be added and final answer will be 0.0, another 0 and 5. That's it. So then Fm equal Fm minus 0.1 into 10. 0.1 into 10 is 1. Equals 0.005. Just take 1 to the other side, then you can subject Fm. So Fm equals 0.005 minus 1 comes to this side as plus 1. Am I right there? Minus 1 comes to the other side as plus 1. So finally, you will get the answer as 1.005 unit is Newton. So this is the force given by the motor. Who got this answer? Lamai? Lamai, who got this answer? Please raise your hand up if you have obtained this answer. Right. Very good. Excellent. Superb. Right. I think time is enough. Let's go. Let's check the next question that they have asked. Right. I think time is enough. So let me check the next question that they have asked. Right. Let me move this up. Roman number 1 we completed. Roman number 2 we have answered. Now we should check for Roman number 3. Right. Read what they have asked in Roman number 3. What are the magnitudes? What are the magnitudes and direction of the force applied by the motor on C during the last 2 seconds? So what will happen to the motion during the last 2 seconds here? What kind of a motion is there during the last 2 seconds? Lamai?
Constant deceleration.
It's a deceleration. Constant deceleration. Very good. So did you write this? I won't erase this because I do not have enough space. Right. Please write them. If not, take a screenshot. I want to erase. So during the last 2 seconds, it has a deceleration. Right. So please write for Roman number 3. Please write. Right. Let me take the graph. Right. This is the graph. Right. Please write. During the last 2 seconds, during the last 2 seconds, the segment C is moving with a deceleration. Roman number 3 and write, during the last 2 seconds, the segment C is moving with a deceleration. During the last 2 seconds, the segment C is moving with a deceleration. Okay, dear? Right. How do you find the deceleration, Lamai? What is the equation? What is the equation of deceleration? From a velocity time graph, how do you find the deceleration, Lamai? Whether it is acceleration or deceleration, always tan alpha, tan beta gradient. So deceleration is also deceleration. You have to find it from the PQR triangle. So deceleration equals tan beta. Write it here, quick. Deceleration equals tan beta. I have written beta in very big size. So how do you find tan from this PQR triangle, Lamai? Somebody please tell me. Which side divide by which side? Lamai?
RQ divided by QP.
RQ divide by, yes?
QP.
QP, very good. RQ divided by QP. Adjacent side, sorry, opposite side, RQ, OQR, divided by adjacent side, opposite divide by adjacent. So RQ divided by QP. OPQ, anything, right? So RQ is, Lamai, what is the length of RQ dear? This side?
0.1.
0.1. Very good. What is QP distance dear?
2 seconds.
2 seconds. Therefore, 0.1 divided by 2 means we get the same value, 0.05. Am I right there? Do not forget the units. So this is the deceleration. So when something is moving with the deceleration means, if we use say acceleration, we should use Lamai. Deceleration is this. So, but if you say it is an acceleration, what should you use there?
Minus sign.
Very good. We must use a minus sign when we use it as a acceleration. Very good. So it means if you use the equation v equal u plus at, or if v equals ma, or any other equations, whenever we use it as an acceleration, we should use a minus sign. That's the meaning. Right. Complete it there. What should I do to find the force given by the motor during the last 2 seconds here? Kamai, what should I do to find the force given by the motor during the last 2 seconds?
Apply F equals MA.
Very good. To which direction here? We should apply F equals MA, but to which direction? Segment C is still moving up. Am I right? Can you hear me clearly?
Yes, sir.
Right.
Yes, sir.
Segment C is moving up. If it is moving up, all the equation should be applied vertically upward. So indicate the direction by a black color arrow and write we apply F equals MA upward. Now listen to me, dear. Still there are 2 forces. Now the new force given by the motor, let me use it as Fm2 or F2. F2 is the force given by the motor. So we don't know its direction here. I'm applying the equation upward. F equals MA is applied upward. Right? So force given by the motor should be upward. That's how I think, because the segment C is moving up. Minus gravitational attraction force always acting downward equals M. What do you think about the acceleration now? Is it an acceleration or a deceleration?
Deceleration.
Deceleration. Therefore, the segment C is moving up with a deceleration of 0.05. But in F equals MA equation, A means acceleration. So if we use the value of deceleration, in the place of an acceleration, we should use a minus sign and we should write 0.05. Why there is a minus sign there? Why there is this minus sign?
Because
Deceleration is considered
Because
as
it's a deceleration. This capital M is 0.1 kilogram. I think you can do the rest and find the value of F2. F2 is the new force given by the motor to the segment C. Start there, find the value of F2 and send your answer to my Zoom chat. Start. Right. So let's see this. F2 we don't know. Minus M is 0.1, G is 10. Equals, now there's a minus sign. See, there is a minus sign. So let me write the minus sign first. 0.1 into 0.05. So when you multiply this 0.1, decimal points is increased by 1. So this will be 0 point, another decimal point will be added than 5. That's what will happen. Who would like if I explain this simplification? Please raise your hand up. Who wants to know how I get this 0.1 multiplied by 0.05 as 0.005? Anybody in the class? Nobody wants. Okay. So this is F2 minus 0.1 into 10 is 1 equals minus 0.005. So let me take this minus 1 to the other side. Let me take this minus 1 to the other side. Minus 1 goes to the other side as plus 1. So F2 equals minus 1 comes this side as plus 1 minus we have 0.005. So if you subtract this, this is much very simple, right? It's so simple. So then you get, if you subtract, you will get this is 0. You have to take this 1 to 1 decimal point. So this will be 10, this will be 10, and this will be 9, this will be 9, and this will be 10. 10 minus 5 is 5. So it means 0.995 Newton. Am I right there? Mama, is this clear? So it means still the force given by the motor is acting upward. That's the meaning. Still the force given by the motor is acting upward. Lamai, please complete this. So we have found the force given by the motor as 0.995 Newton during the last 2 seconds by applying F equals MA vertically upward. Who got this answer? Raise your hand up if you have obtained this answer. Very good. Excellent. If you have any doubt or any difficult point, send a message to the Zoom chat. Right. Shall we go to the next question here? Who wants more time? Now, please raise your hand up if you want any more time to write the things. Right. So let's go for the next question. Let's give a try. We have answered Roman number 1. We have answered Roman number 2. Roman number 3. What are the magnitude and direction of force applied by the motor on C during the last 2 seconds? The direction is upward. If they ask you to write the direction, please write direction of F2 is upward. Direction of F2 is upward. Please write it here because they ask a direction. Direction of F2 is upward. Now let's try for Roman number 4. Suppose the magnitude of the force, I'm talking about Roman number 4. Suppose the magnitude of the maximum force that the motor can deliver is 12 Newton. Is it 12 Newton or 1.2 Newton? Let me check the question paper one more time because there was many typing mistakes. Suppose the magnitude of the maximum force that the motor can exert on C is 1.2 Newton. I'm so sorry. Please correct this as, please correct the mistake as 1.2 Newton. Maximum force that the motor is able to give is 1.2 Newton. This is 1.2 Newton. Unfortunately, it is printed as 12 Newton. Suppose the magnitude of the maximum force that the motor can deliver is 1.2 Newton. If the start from rest, C moves up under this maximum force for 0.5 seconds, how far will it move? Can you understand it? Suppose the magnitude of the maximum force the motor can exert on C is 1.2 Newton. If starting from rest, C moves up under this maximum force for 0.5 seconds, how far will it be moved? So first of all, what should you do, dear? We know the force, we know the mass. They ask us to find the distance traveled by the motor. So what should the distance traveled by the segment C? So what should we do, dear? Lamai?
Find acceleration.
Find the acceleration. Very good. That's it. So for Roman number 4, for the Roman number 4, vertically upward, let's apply F equals MA. That's what we want to do. The upward force is the force given by the motor, Fm. The downward force is mg. Equal mass is 0.1, and we don't know what the acceleration is, 0.1 into A. Can you do the rest and find acceleration, dear? The first thing that you want to do is find in the acceleration under this maximum force. Right? Right. So the new Fm is 1.2, capital M is 0.1, G is 10. This is 0.1 into A. Can you do the rest and find the value of simple A? Simple A is the upward acceleration of the segment C under the maximum force of 1.2 Newton. Find the answer and send your answers to my Zoom chat. Start. Interesting. Many answers are given. This is 1.2. 0.1 into 10 is 1 equals 0.1 into A. 0.1 into 10 is 1. So what is 1.2 minus 1.2 minus 1 there? 1.2 minus 1 is, yes dear?
0.2.
0.2 equals 0.1 into A. Now, very simple. I can write 0.2 as, look at board, I can write 0.2 as 2 divided by 10. Right? So, there are simplification method. 0.1 can be written as 1 over 10. Am I right there? Right? Into A. What did I do? I have written 0.2 as 2 divided by 10. I have written 0.1 as 1 divided by 10. So then what will happen? This 10 and 10, this 10 and this 10 cancelled out. Finally, you will obtain that A equals 2. Only 2 will be there. 2 meters per square second. Who got this answer, Lamai? Right. So they ask maximum velocity. If this force is applied for a period of 0.5 seconds, what is the maximum velocity obtained by this segment C? What should I do to find the velocity here? That's an acceleration of 2 meters per square seconds. The force is applied for a period of 0.5 seconds. So it means the object moves with this acceleration of 2 for a period of 0.5 seconds. So what should I do to find the velocity? Lamai, what should I do to find the velocity? You are tired, right? So it's so simple. Just yes.
Plus U plus 80.
Very good. Yes. To the upward direction, apply V equals U plus 80. So it starts at from rest. It means initial velocity 0. Acceleration, we found it as 2. Time taken, they have given it as 0.5. So what is 2 into 0.5 here? This is 0 plus 2 into 0.5 means 1.0. 0 plus 1.0 means 1. Am I right here? What is the maximum possible velocity? Lamai? 1 meter per second. Am I right here?
Yes, sir.
So what is the displacement here? I think they have asked in the next question, they have asked the displacement also. If they ask you to find displacement, what should you do? We found the velocity. The segment C is moved under this maximum force of 1.2 Newton for a period of 0.5 seconds. We want to find the velocity also. So we want to find the displacement also. How do you find it?
SC का 60 plus half AD square.
SC equal UT plus half AD square. Yes, very good. So let us apply along the upward direction. Along the upward direction, let us apply S equals UT plus half AT square. Can you do the rest? Can you do the rest and find the displacement? Send your answers to my Zoom chat. Start, Lamai. Send your answers to my Zoom chat there. If you have found S, send me the value of S. Let's see. Initial velocity is 0. So it means U is 0. Time is 0.5 plus half into acceleration is 1. Time is 0.5 and you have to get the square. Time is 0.5 but t square 0.5. This is t square. What will happen there? 0 into anything is 0 plus half. Let me write half as half.
So acceleration is 2, right?
Accelerate. Yes. I'm so sorry. Acceleration is 2. Yes. Why not? Acceleration is 2. This is 2. Right. Then what will happen? Yes, actually, yes, acceleration is 2. Then what will happen here? Into what is 0.5 square here? 0.5 square is 0.25. Now this 2 and this 2 cancelled out. So the displacement will be, Lamai? What will be the displacement there?
0.25.
0.25.
Very good. That is 0.25 meter. Do not forget the unit. In meters, it is 0.25. If it is in centimeters, it will be 25. Who got this answer here? Who got this velocity and displacement? Answers correctly. Velocity 1 meter per second. Displacement is 0.25. 0.25 meter means 25 centimeters. Very good. Many of you have obtained the correct answer. I'm so happy. Complete it there. Right. We have answered in this question up to simple A, Roman number 1, Roman number 2, Roman number 3, and Roman number 4. Right. So we should try for the next part of the question. Right. So let me go to next side of the page. Right. So this is the next part of the question. Right. In part B, simple B part, next consider a rotational motion of segment B together with the segment C occurring the round joint 2. The angular velocity time graph is shown in figure 3 for this situation. Segment B rotating about joint 2. What is joint 2, dear? This one. About this point, this segment B rotates with the segment C. So about the point 2, joint 2 mean point 2, the section B rotates. When it is rotating, segment C also rotates. Right. Let's go to the other page. Right. So we came to the page. Next, consider the rotational motion of segment B. I have showed you the segment B together with the segment C occurring around the joint 2. The angular velocity time graph is shown in figure 3. So this is figure 3. What do they ask? Assuming that segment A is held fixed during this rotational motion. So segment A is not moving, only B and C sections are rotated. Actually, the segment B rotates about the point 2. The moment of inertia of the combined system of segment B and C around the axis of joint 2 is 0.01 kgm square. The moment of inertia of the segment B and segment C about the point 2 is given as 0.01 kgm square. Moment of inertia given. Calculate the torque applied by the motor during the first 4 seconds of the motion. So during the first 4 seconds, what will happen there? Right. First of all, say in simple B, whether you have obtained the answer or not, say in simple B, draw this graph there. Say in simple B, draw this graph. And somebody unmute the mic can tell me within the first 4 seconds, what has happened here? What kind of motion is this there? Lamai, this is the first 4 seconds.
Constant acceleration?
Yes, velocity increases. If velocity, this is 4 seconds. If velocity increases, it's an acceleration. What is this height here? Somebody please tell me, what is this height? It is 0.5. Very good. It's given 0.5. Right. Draw this graph. So during the first 4 seconds, angular velocity increases from 0 to 0.5. That's what they have. That's what given in the graph. Right. Now somebody unmute the mic can tell me what has happened to the angular velocity during the last 4 seconds. Lamai, this is the final 4 seconds. Right? 4, 5, 6, 7, 8, 4 seconds. During these 4 seconds, what has happened? Is it acceleration or deceleration?
Deceleration, sir.
It's a deceleration. So please mark during the last 4 seconds, it has a deceleration. Right? Draw the graph and mark these data. So when the graph is with the answers, it's easy for you to understand. If I wish to find acceleration, I have to find the gradient. Therefore, I have to mark these angles. Right? So let me consider this angle as, you can use any letter as you wish. Let me use this angle as alpha. You can use any letter as you wish. and let me use this angle as beta, right? So please mark alpha and beta, right? So to find the gradient, we need alpha and beta angles. So we are discussing this question before we start our new lesson. Complete, dear. Draw it. Draw the graph. Right. So let's find angular acceleration. Angular acceleration during the first 4 seconds. How do I find it, dear? What should I do to find it? In a way, whether it is angular velocity graph or linear velocity time graph, always angular acceleration is given by Lamai
Tan alpha.
tan alpha. Very good. So angular acceleration during the first 4 seconds is gradient. Gradient mean here tan alpha. So please write this is equal to tan alpha. Can you find acceleration and send you answers to my Zoom chat, dear? Find angular acceleration and send you answers to my Zoom chat. Start. So I'll give you a help. Tan means opposite side divided by adjacent side. The opposite side, height of the opposite side is 0.5. Adjacent side is 4. So what should be this, dear? Lamai? Yes, many of the students send me the answers. I'm very happy. Very good. So 0 divided by 5 is 0. Sorry, 0 divided by 4 is 0. 5 divided by 4 is 1. 4 times 1 is 4. 5 minus 4 is 1. Again, here, as we have put the decimal point here. For that one, we can convert into 10. 10 divided by 4 is 2. That is 8. 10 minus 8 is 2. 20 divided by 4 is 5. So this is the answer. And do not forget to give the units. What's the unit, dear? Radian per second. Do not forget the units, dear. Because I have seen that sometimes students, they do not write the units. So this is an acceleration. Right. Who got this answer? Please raise your hand up. If you have obtained this answer in Zoom chat, please raise your hand up. Very good. Many of you have obtained the correct answer. Right. Now, Roman number 1, calculate the torque applied by the motor B during the first 4 seconds. So what is the answer for B Roman number 1 day? So B Roman number 1, they ask us to find the torque applied by the motor. To find a torque, actually, there are 2 equations. Which equation is more suitable for here? Lamai, which is the best equation?
Moment of inertia into angular acceleration.
Very good, excellent. So torque equals I alpha. Please write the equation and find the torque there. Start. Send your answers to my Zoom chat. Torque equals I alpha. Torque equals I alpha. So while we are covering the syllabus, it's very important to discuss the past paper questions, but do not forget my new questions too, right? I have given you 100 questions, 100 new questions for the circular motion tube. Before I give you the next tube, please complete it here, right? So it's a must to discuss both new questions and past papers. Do not forget my tube. If you have not received the tute, I think even I have sent you the PDF and a PDF also, right? Try all the questions of that tute. Right. Torque equals I alpha. I is equal to 0.01. Alpha is, we have found it as 0.125. So what is the answer? The easiest method to simplify this is 0.01 can be written as 1 over 1000, right, into 0.125. So it means actually the multiplication here 0.01 into 0.125 means actually 0.125 divided by 1000. So what is the answer here? Let me help you further. 1 over 1000 can be written as, let me help you for the simplification. 1000 can be written as 10 to the power 3. Am I right there? So 1 over 1000 can be written as 10 to the power 3. Multiply by 0.125. Clear here? So the next step, in the next step, let me take this 10 to the power 3 upward. 10 to the power plus 3 comes up as 10 to the power minus 3. Am I right? Am I right, Lamai? Into, wait, 0.125, Lamai, 0.125. Let me write, please try to understand my mathematical simplification methods. Please try to understand that 0.125 can be written as 12.5 divided by 10. Am I right? Clear or not?
Clear, sir.
0.125 can be written as 1.25 divided by 10. 10 can be written as, look at board carefully, 10 can be written as 10 to the power 1. Am I right? Because some students consider these simplification methods are difficult. That's why I'm giving you this help. 0.01 is written as 1 over 1000. 1.25 is written as, sorry, 0.125 is written as 1.25 divided by 10. Right?
Sir, is it 1 over 100, sir?
Why 1 over? Yes, 1 over 100. Sorry, it should be 1 over 100. Yeah, 0.01 means 1 over 100. Yes, sorry. That will be 3 with this one. I'm so sorry. With this is 10 to the power 2. Now, okay, right. 1 over 100. Now, are you okay up to this point? 0.01 can be written as 1 over 100. 0.125 can be written as 1.25 divided by 10. 10 means 10 to the power 1. 10 to the power plus 2 comes up as 10 to the power minus 2. Nothing will happen to this 1.25, and this 10 to the power 1 comes up as 10 to the power minus 1. This 10 to the power 1 comes up as 10 to the power, sorry. This 10, what has happened? This 10 to the power 1 comes up as 10 to the power minus 1. Am I right? So finally, what is the answer here? Finally, finally you will get that 1.25 into 10 to the power. This is minus 2. This is minus 1. Altogether minus 3. Unit is Newton meter. Who got the answer up to this level? Who are able to simplify and get the answer up to this point, please raise your hand up there. Lamai, please raise your hand up if you got the answer up to this level. Very good. Complete the simplification there. Let me move this a little bit upward, otherwise it will not be clear for you. Right, complete the answer. Check whether, I think math students, they don't want this much of help for the simplification, but there are bio students also. Even some math students, they are not familiar with this kind of simplifications. That's why I showed you all the mathematical simplification steps. Some students, they don't want, but some students, there are some students, they really need this simplification guide. Complete it there. Right, I'll keep the answer somewhere here so you can complete it. Let me go for the next question. Let me check the next question. Look at board. B Roman number 2. What is B Roman number 2 there? Calculate the angular displacement of B during the 8 seconds of period shown in the figure 3. Angular displacement, how do you find it there? in Roman number 2, it is asked you to find the angular displacement. From a velocity time graph, whether it is angular motion or linear motion, how do you find angular displacement? Lamai?
Right, the area.
Very good. From a velocity time graph, easiest thing to find the displacement is area under the graph. So Roman number 2, please write displacement or angular displacement. Angular displacement equals area under the graph. Area under the graph, please write. Area under the graph. So what kind of a graph is this, dear? Lamai, what kind of a graph is this? It's a Lamai. What is the shape of the graph? Okay. What is the shape of the graph? Rectangle or triangle or a circle? What is it?
Triangle, sir.
It's a triangle. So what is the area of a triangle? What's the equation? That is half into Lamai.
Base into perpendicular height.
Base into perpendicular height. So what is the total base there? If you consider the entire triangle, the base is how many circles there?
8.
8. Perpendicular height for the entire graph. What is the perpendicular height? This one. 0.5. 8 means this 0 to 8. 8 seconds. Perpendicular height 0.5. 0.5. So 8 divided by 2. Here 4 into 0.5. So what is 4 into 5 here? That is 2.0. Unit is radian. Angular displacement has the unit of radian. Is there anybody who got this answer earlier than me before I explain? Or is there anybody who got this answer at home? Very good. Excellent. So this is the answer for Roman number 3. Complete it there. Shall we go for Roman number 3, Lamai?
Okay, sir.
What about the screen here? Is video clear or not?
Clear, sir.
Okay, thank you. What about others? Is video clear for all?
Clear,
Yes,
sir. Yes.
Right. So I'll erase the things that I've written already, and I'll go for next question. But if you want any more time to write the things, please take a screenshot. I'm going to go for the next question. Look at board. So we have found the angular displacement, right? So let me check the next question. Roman number 1 we complete. Roman number 2 we have answered. Roman number 3. If the magnitude of the maximum torque, that can be applied by the motor is 0.002. To rotate the segment B, there is a motor. The maximum torque that the motor is able to apply is 0.02. Unit is Newton meter. What is the minimum time that will take for capital B section, segment B actually, to start from rest, RST mean rest, and comes to rest again after an angular displacement of 3.2 radian? What should happen there? Now what should happen? Look at board. If I draw another velocity time graph, angular velocity and time graph, right? So what's the condition that must be satisfied here? If the magnitude of the maximum torque that can be applied by the motor is 0.02, what's the minimum time that will take for B to start from rest and come to rest after an angular displacement of 3.2 radian? The best thing is drawing a graph. If you have not learned graph, you must send a WhatsApp message to me. So I'll let you know the next time that I reteach this graphs, dear, right? Okay, dear. So you must send a WhatsApp message to me so I can help you to cover the graph section if you have not learned it with me or if you have missed it, right? So let me draw a new graph for the question. So here the velocity is 0, time is 0, and velocity is also 0. So what should happen there? The object should start the motion at rest. The object should start the motion at rest, and it reaches to a certain maximum velocity, and finally it comes to rest. During that, the displacement, angular displacement should be 3.2 radian. This is what I want. This is what we want to satisfy. This is the condition that we want to satisfy. Right? Look at board here. Starting from rest, obtain a certain maximum velocity and comes to rest again. Right? So they ask us to find the total time taken for this motion. Look at board here. Here, as earlier, the time period was 8 seconds. How they have divided the 8 seconds here? How the 8 second is divided here? 8 seconds were divided as 4 seconds and 4 seconds. Am I right? Lamai?
Yes, sir.
Very good. So here, let me take this is simple t seconds, and this is simple t seconds. This is also simple t seconds. Then what is the total time taken?
2t seconds.
2t seconds. And here we don't know the maximum velocity. We don't know the maximum velocity. So let me take maximum velocity as, I can use anything, this velocity as omega. I don't know what the omega is. Let me it as omega O, omega M, anything, okay, right? So the velocity obtained by this is omega M for maximum. Draw the graph for Roman number 3. Please draw this graph here. This is for simple being Roman number 3. Draw the graph. Right. So let's try to mark the other thing is we can find angular acceleration here also. Yeah, we have to find angular acceleration. So let me mark this angle as theta radian. Sorry, theta degrees. So please mark this angle as theta. Right, because we have to calculate the gradient. Mark this angle as theta. Right. Because first of all, we should find the acceleration, angular acceleration. Right. Look at board here. So what is angular acceleration there? From this graph, Lamoy? Hello?
Tan theta.
Tan theta, very good. So angular acceleration is tan theta. Can you do the rest and obtain any expression? I think we will not be able to obtain a value for angular acceleration, but we will be able to obtain at least an expression, right? So angular acceleration we cannot find directly, but we can write it as opposite side. So what is this length here? What is this height? This height. What is this height?
Omega.
Omega m. Ne? So I have marked that height as omega m. This height is, please mark this as m for maximum. That is the maximum velocity obtained by the answer. So angular acceleration means tan theta. Tan theta means opposite side. Opposite side. Length of the opposite side is omega m divided by what is this length there? Omega m divided by opposite side divided by adjacent side. Adjacent side is simple t. Write it there. So we have obtained an expression for angular acceleration. Omega m divided by t. Complete it there. Right. So then they have given us the maximum torque value. Can you see that point, Lamai? See, the maximum torque is 0.02. Did you see this, Lamai? Ligel?
Yes, sir.
Ah, yes. Right. So let me use that equation. Torque equals, what is it? I alpha. Write it here. Lamai, please write. Torque equals I alpha. Now we have alpha mean angular acceleration. We have an expression for alpha. So alpha means this, omega m over t. Am I right, dear?
Yes, sir.
Right. Very good. Others also, please, others also speak, dear. When students talk to me, I'm very happy. So torque is 0.02. Moment of inertia of section B. What is it, dear? Moment of inertia of section B with the section C is given as 0.01. Alpha is found as omega m divided by simple t. Write it, dear. Write it. Omega m is missing. So alpha is omega m divided by t. Can we simplify this any further? What can we do to simplify this further? Think. One of the way to simplify this is, this can be written as 2 over 002. So it can be written as 2 over 1000. Am I right there? 0.02 can be written as 2 over 1000. I think you can understand it. And 0.01 can be written as 1 over 10. No, 1 over 100. And we cannot do anything to this omega m over t. We cannot do anything to this omega m over t, like this. Complete it here. I'm not going to change the term omega m over t. Right. So finally, I'm just writing the simplification steps. Finally, two of these zeros, this 0 and this 0, can be cancelled out with these two zeros. It means now we have obtained an expression for omega m over t. Now we have obtained an expression for omega m over t. Okay, dear? So what is omega m over t, dear? 2 divided by 10 means 2 divided by 2 is 1, 10 divided by 2 is 5. So what is omega m over t, Lamoy?
Acceleration, sir.
No, I'm asking the value.
105, sir.
0.25.
1 over 5, very good. So omega m over t is 1 over 5. Please write it there. Omega m over t equals 1 over 5. That's what I wanted to obtain. I have slowly explained the things because you need to understand it. If I am hurry in teaching, you will not understand the things. So it's useless. I want everybody to understand. So I have obtained an expression for omega m over t. Complete it there. If you want, you can find alpha directly. Alpha will be actually this is actually you can directly find alpha by using Tute equation. Once you find alpha, then you can use the linear angular motion equations. Omega 2 equals omega 1 plus alpha t. Yeah, that is also possible. No problem. Even that method is also okay. But I want to use purely the graph here without using any other thing. Right. So what is angular displacement here? Angular displacement, Lamai? That is area under the graph. Am I right, dear?
Yes, sir.
Right. Area under the graph. Right. So they have given the angular displacement. What should be the angular displacement, dear? Lamai? Me?
3.2 radian.
3.2 radian. Very good. 3.2 radian equals area under the graph. So this is a triangle. So area under the graph means half into base into, what is the base there now? Base is t plus t, ne? T plus t into what is perpendicular height?
Omega m, sir.
Omega m. Complete it here. Let me write it like this because it's very difficult for me to write omega m. So I have written wm. I think you can understand it. So next step, I can take 2 to the other side. Next step, I can take 2 to the other side. Oh, okay, I'll keep 2 as 2. 3.2 equals, I'll take 2 to this side. 3.2 into 2 equals, this side you have 1 into t plus t is 2t into omega m. Check whether you can understand these things. 102 means area of a triangle. Area of a triangle is half into base into perpendicular height. That's how I got 102 here. So I take 2 to the other side. T plus T is the base, length of the base. That is 2T. Right. Now, can you see something like this here? I'm just want to use purely the graph. That's my that's what I want. From this, we can obtain an expression for omega m. What is omega m according to this here? What is omega m according to this? Just take t to the other side. So it will be t over 5. Am I right? Omega m is equal to just t divided by 5. Check whether you can understand this here, Lamai.
Yes, sir.
Right. What about others? Please raise your hand up if you are okay with this. Omega m equals t over 5. Lamai, please raise your hand up. If you have understood this point, please raise your hand up. Okay, very good. Nice. Now we have the answer. Now you should identify that these two and these two can be cancelled out. You see, these two and these two can be cancelled out. So what are the remaining terms there? Here I have 3.2. The other side I have t because 2 cancelled out, and I have omega m. What is omega m according to this there? According to this, omega m is t divided by 5. Can you find t from this there? Can you understand here? For the omega m, I have used t over m from this equation. Instead of omega m, I have used t over 5. Right. So what is t into t here? You can take 5 to this side, then you get, if you take 5 to this side, you will get 3.2 times 5 equals t into t. What is t into t?
T square.
T square. 3.2 times 5. 5 times 2 is 10. You can put a 0 there. 3 times 5 is 15 equals t into t is t square. If t square is 15, what is t dear?
Square root 15.
Square root of 15. So please complete it here. So finally we get, but this is not the answer, right? Finally we get t equals square root of 15. The unit is seconds, but this is not the answer. What should be the answer?
So it's 16, sir.
Sorry?
Sir, it's 16, right?
Yes. 5 times 2, 10. 1 remaining. Yes, 16. Sorry. This is, sorry. 5 times 2 is 10. You write the 0, remaining 1. 5 times 3, 15. Remaining 1, 16. So what is square root of 16 then?
4, sir.
4 seconds. Please complete there. Is there anybody who got this answer earlier than me? Anyone? Very good. Right. So therefore, what is the total time there? What's the total time? T is only the half of the time. So what should be the total time then? Lamai?
8 seconds, sir.
8 seconds. Very good. Total time is 2 times T. You think? T is 4. And 2 times T can 2 into 4. 2 into 4 means 8 seconds. So I have written so many, almost all the steps because I just wanted all of you to understand the question. So I was not in a hurry when I was discussing frictions. Completed here. So this is the complete answer for B, Roman number 3. Right, let's go for the next question. I think we have only one more question to be answered. So that will be there, and it will be the end of this 2012, yeah, 2012 mechanics essay question. So if you want any more time to write the things, please take a screenshot. I'm going to erase everything. If you want any more time to write the things, just take a screenshot. I'm going to erase everything. Right. What is the final thing that they have asked? C, simple C question. Now, segment capital A is allowed to rotate freely around joint 1. What would be the direction of the rotation of segment A? When the segment B starts from rest and rotates clockwise around joint 2. Now the segment A is allowed to rotate freely around the joint 1. Earlier, we have applied brake and we had the mechanism to stop the segment A when B is rotating. What would be, now A is free to rotate. What would be the direction of the rotation of segment A when the segment B starts from rest and rotates clockwise around the joint 2? Give the reason for your answer. So let me check this figure here. According to this figure, if segment A rotates to one direction, if B rotates to one direction, B is rotated about the segment A. If A is free, as initially everything was at rest, do you remember the law of conservation of angular momentum here? The law of conservation of angular momentum. Do you remember this? According to this, what should happen here? Initial angular momentum, let me use AM, should be equal to final angular momentum. Initial angular momentum should be equal to final angular momentum. So therefore, initially both A and B were rest. If A rotates to one direction, B should rotate to the opposite direction. I can easily prove it. Initial total angular momentum means moment of inertia of segment A into, initially the A was rest, plus moment of inertia of segment B into, initially it was at rest. Now what has happened? Moment of inertia of A into angular velocity of A should be equal to moment of inertia of B into angular velocity of B. Now you should understand that what is the value of this side there? Initial total angular momentum. What is the value of this side?
0, sir.
It is 0. It is 0. So finally we will get 0 equals moment of inertia of segment A into its angular velocity plus moment of inertia of segment B into its angular velocity omega B. Now if I take this term to the other side, what will be its value here? IA omega A comes to this side as Lamai. Positive
Minus
something
IA omega
other
A.
side. Yes, dear, again
Minus IA omega A.
minus. So it should come to this side with a minus sign. That's it. Equals to IB into omega B. This minus sign indicates that rotating direction of B, A and B are opposite. So this is, if you want, you can write this much of a very big description, but no need this much of a description. If you want, you can write this as a note separately. The answer for simple equation is into the anti-clockwise direction. Answer for part C is into the anti-clockwise direction. Reason is because of the law of conservation of angular momentum. Segment A rotates into the anti-clockwise direction. Reason, because of the law of conservation of angular momentum. Reason, because of the law of conservation of angular momentum. Right? Now, if you want, you can write this note, and that is the end of the 2012 mechanics essay question. That is the first essay question of the paper. Completed, dear. Right. Now I'm going to start a new section that is fluid mechanics. Right. So if you want any more time to write these things, you may take a screenshot. I'm going to erase everything and I'm going to start the final section of mechanics lesson, fluid. Right. I think you had more than enough time to write the note. If not, send me a message after the class, then I can send you the screenshot of the whiteboard if you are not able to write the note, the previous note. Right. So for the fluid mechanics, 80 pages single rule CR book is enough. But if you have a circular rotational motion book, if you have more pages in circular and rotational motion book, just divide it into 2 sections and write the heading as fluids. Right. You need some more pages for the circular rotational motion because I wish to discuss more questions, including the first tune that I have given for the circular motion. I think I have discussed some of the questions, but not all the questions. Even there are many past paper questions also. To discuss some past paper questions and new questions, it's better to keep few more pages in circular motion book. Right. So today's heading is fluids. What is a fluid, dear Lamai? What is a fluid? Somebody? If somebody tells you that there's a fluid in a vessel, what does it mean? Okay, write the heading as fluid and write, no, people were damn silent. So please write the note. A fluid is a common term used for both gases and liquids. A fluid is a common term used for both gases and liquids. A fluid is a common term used for both gases and liquids. That's the simplest definition for fluids. Right. So we have reached to the end of mechanics lesson. Within 2, I think we were disconnected. Right. I think we were disconnected and I think now we have reconnected. So actually I have given the heading as fluids, the final section of mechanics. So please, I have given a note saying that fluid is a common term used for both gases and liquids. Fluid is a common term used for both gases and liquids. This is for both gases and liquids. Fluid is a common term used for both gases and liquids. Write the first subheading. Write your first subheading as density. Density. Right. What is the normal symbol that we use for density, dear? Lamai? You can use two symbols. What is the most famous symbol here? Rho. Most famous symbol is rho. Right. So please write density as your subheading. Within brackets, please write rho. Rho is the symbol that we use for density. Right. Rho is the symbol that we use for density. What is the definition of density, Lamai? Density is the mass per unit volume. What's the equation that we use to find density? Please write them all. What's the equation that we use to find density? O level. Somebody please tell me quickly.
Mass over volume.
Very good. Density is mass over volume. Write it. Density equals.
Mass over.
Very good. Yes. Mass over volume. Write it and please draw a box around it. It's a very important equation. Right. What is the unit of mass here, Lamai? What is the SI unit that we use to measure mass, and what is the SI unit that we use to measure volume? Lamai? Mass?
Kilogram, sir.
Mass is measured by the SI unit of kilogram. Very good. What is the SI unit of volume?
Meter cube.
Yes, meter cube, cubic meter. Therefore, what should be the SI unit of density? SI unit of density. Yeah.
Kilogram meter per cube.
Kilogram per meter cube.
Very good. Kilogram divided by cubic meter. Cubic meter comes up with the minus sign. So SI unit of density is kilogram per cubic meter. Complete this, dear. Write them all.